Welcome to the cryptocurrency infrastructure panel. This is going to be an incredible panel. Our panelists include Matt Spoke from Ion, Adam Perlow from Zen Protocol, Justin Fisher from Veriblock, Ben Jessel from Kadena, and Konstantin Richter from Blockdaemon. And Konstantin will be moderating. If you want to go ahead and take it away.
Sure, hi. I'm Konstantin Richter. I'm the CEO and co-founder of Blockdaemon. The way and what we're going to do here is we're going to do a quick round of introductions. We have a very interesting group of people involved in projects that are somewhat in relation to the subject of infrastructure, and infrastructure meaning not distribution infrastructure necessarily, but actually the hard bare metal infrastructure that allows you to deploy applications and blockchains. And so we're at Blockdaemon, we're sort of the bottom of the stack. We run our own data center, and we're a nodes as a service company. The key differentiator for us is that we're multi-cloud. One of the big things for us is that we don't like to see the projects who are deploying decentralized applications and then every node is on Amazon. We like to offer our networks across Amazon, Azure, DigitalOcean, and our own structure to ensure that it's a truly decentralized application. We also work with every major blockchain protocol, and so that's me. Matt, you want to say who you are and
Sure.
give a quick intro of Aeon? I think so. No?
No? Can you hear me? Hello. All right. My name is Matthew Spoke. I'm the founder of a project called Aeon. Aeon is a protocol that we've been developing for the last about 12 months. Majority of our team is in Toronto, offices in Barbados and Shanghai and Romania as well. The focus of the protocol is essentially twofold, one being on-chain scaling. There's a couple of layers we'll talk, I'm sure, about the layers of the stack that lead to scaling limitations on public blockchains. And then the second layer that we're focusing on that I think we're probably more known for is this idea of interoperability between blockchains. How do you essentially allow for transactions to flow between networks such that you could start to write applications that have bits and pieces of their logic and transactions that are sitting natively on different blockchains. So that's kind of our focus. And we're a day away from launching our public network, so exciting week for us.
And can you also say, do you have how are you incentivized, via token or equity, or just each one of you when you introduce yourselves, do you have a token?
Yeah, so I mean the Aeon protocol is powered by its own native coin. We launched it as an ERC20 token when we announced the project last year. So that token is in circulation and trades and all that good stuff. But then as we launch the protocol, then we migrate the token supply over to the native coin of the protocol.
Thanks, Matt. Check, radio check. Hi, my name is Justin Fisher. I'm the co-founder and CEO of Veriblock. What Veriblock does, in a nutshell, is we seek and attempt to secure the world's blockchains using Bitcoin. So we see Bitcoin as the world's greatest form of proof of work. They've got more hashing power combined than over 500 of the top supercomputers in the world combined. And right now, it's currently securing Bitcoin itself. So our model and narrative is to stay kind of blockchain agnostic, let other blockchains decide what they're going to use for their consensus protocol, how they're going to solve or attempt to solve problems in the world today using blockchain technology, and simply use Bitcoin security to help them have another layer of security. This is really important when it comes to nascent blockchains because they may not have attracted enough mining power to properly secure their network. And that's kind of where we come in. So any blockchain that's new, intermediate, or quite large, or even just susceptible to double spend attacks, we can offer them a level of security that they're not otherwise going to get, particularly when they're starting. In addition to that, we also supply exchanges and the like with early attack detection metrics, which allows them to offer better solutions and more features and faster transaction times to those blockchains that they provide markets for. So that's kind of what we do in a nutshell. We did our testnet out of Token Fest last month. Things are going really well. We're really happy with where we're at. We did that as closed source binaries, but we're going to be going open source. We're scheduled here Q2 to go open source. We are a blockchain. VeriBlock is the implementation of our new protocol that we term proof of proof. And we are a traditional blockchain, and we have coins, and that's how people use the utility of that proof that we talk about, that security. Thank you.
Hi everyone, my name is Ben Jessel and I am Head of Business Development for Kadena. Kadena is a next generation platform for doing business on the blockchain. It was founded by the ex-JPM guys that came out of Quorum, out of Juno more specifically. And we're about up to 10 folks now. We just closed on their funding round as of the last couple of weeks. So what we're trying to do is fix some of the systematic issues with blockchain that we believe has stymied the growth and adoption of blockchain up to now. And we have a private chain, a public chain, and then a smart contracts programming language, which is open source and free for anyone to use today. So the kind of challenges we're looking to solve is speed and scalability. So currently private chains are a few thousand transactions a second, no more than about 10 nodes. We believe that we can push that further, and we've proved that with a Fortune 500 company that are using our product now. And then on the public side, again, we see that it's not just scalability that's a challenge, but also a lot of the languages that are used for smart contracts are just too complicated. They're not designed for blockchain, they're designed for everything. And that causes a number of challenges, as you've seen with the parity bug and other hacks that have happened because of the complex nature of the programming languages. So we're looking to solve some of those structural inefficiencies through that, number one, scalability, the speed, and then also with this pared down programming language that can improve some of that stuff. Our public chain is a level 1 scaling solution, which is fairly rare in the industry today. So we've just completed on a pre-sale of tokens. We will have a utility token, which will be launched at the end of this year, and we're going to be in test net in the summer.
Hello? Mic working? Okay, thank you. Hi, my name is Adam Perlow. I'm one of the founders behind Zen Protocol. So we've been working on this project for about 2 years, and what we've done in that time is essentially, number one, Zen is a project focused on finance. Why do we do that? Well, I actually think that one of the only things the blockchain is actually going to excel at and be good for is financial transactions. It's one of the only things that actually justifies the amount of resources that go into this kind of decentralized computation where everyone has to verify, the whole history that happened. Now, what essentially differentiates us? Today you have, I'd say, 3 paradigms of decentralized computation. You have one model, which is Bitcoins. It's commonly known as the UTXO model. Essentially, what you have is you have a transaction, you look at the size of the transaction, and based on the size of the transaction, you decide how much you're going to pay. But the thing is, with this UTXO model, how does this work? Well, it works by the fact that you have to limit what you can write. You can't have smart contracts, right? That's why Ethereum was built, and Ethereum had a language which can express itself more. So you can have loops, you can have recursion, you can have that kind of stuff. But the price for that, the price for having these loops and recursion and a more expressive language is the fact that you have to give up on the UTXO model, and you have to go to a virtual machine. And this virtual machine has a counter in it that has gas, and it essentially everyone sits together and they're going to count together how many steps it takes to execute your computation. And we've essentially designed a third model. And in this third model, essentially we take a language built by Microsoft Research and INRIA, which is like the chief scientist of France, and talking about what Ben was talking about, essentially languages specified for smart contracting platforms. It's a language where you can prove certain assertions. So we can essentially prove that it's going to take X steps to do your computation, and by doing that, we can get rid of a virtual machine, and by doing that, essentially, we can have a much faster and better paradigm. So I think that it's essentially like a nice middle ground between, having the simplistic design of Bitcoin, but also having the expressibility that you kind of have in things like Ethereum.
Great. And so from my sort of not as technical world, so the complexity of the infrastructure is scalability and throughput, right? So a lot of the blockchains that currently exist aren't easily scalable. The cost of doing so is very high. And then the other one is throughput, which is simply based on the fact of the decentralized nature and the way how all nodes need to sync. And so just maybe Justin, can you talk a little bit about, because when I looked at your site and you have a proof-of-proof consensus model, talk a little bit about how hashing and mining works when it comes to a blockchain and what the respective scalability issues are. And how do you guys actually, what does Veriblock do in order to enhance that?
Okay, so hashing, how about if I give you a metaphorical example? I'll try to do this briefly out of consideration of the rest of the panel. So I like to think of proof of work, or hashing, if you will, in more about the hashing itself, but what does it actually do? Why is it important? So imagine, for example, if you were to drill 2 holes in the ground, and you were to put these tubes down there that were impenetrable tubes, and whatever you put at the bottom of the tube, on one side, you put the same on the other side. And now imagine on the left side where you dropped a diamond ring, you were to pour some molten steel. And on the right side, you were to pour oatmeal. Technically speaking, both of these 2 items are covered, but one is going to be more difficult to penetrate once it cools than the other. And I like to think of that cooling period as kind of like the time maybe it takes to hash a block. You're putting this thermodynamic energy forth. And the problem right now is that, so let's continue that paradigm briefly. On the left side, we've got this molten steel, and after 10 minutes, it hardens. And on the right side, you've got a diamond ring. Somebody's going to say, I'll spend the energy to go down there and scoop out the oatmeal out of the way and grab the diamond ring. On the left-hand side, depending on the value of the diamond, it could be more expensive to drill through the steel and all the effort to go through and get that diamond. So on the surface, you could say, hey, we've got, these are 2 of the same blockchains, but one's being poured with molten steel. So as that pertains to hashing, that's kind of how we see the paradigm. And then imagine in 10 more minutes, someone else is going to put a diamond. You're going to pour another layer of molten steel and another layer of oatmeal. Now you've got 2 layers of steel you have to go through to get to the diamond at the bottom. So the beauty of that is that in a proof of work model, once you pay for that security, it continues to become more secure. And that's a really profound idea. Well, how can we leverage that and take it beyond just Bitcoin? That's where proof of proof comes in, and I'll yield to the time here and circle back to that about what proof of proof is. But that's how we see hashing. We see it as these, these tubes, and this layer keeps building up. One's going to be harder to penetrate than the other.
Okay. And then Adam, maybe, Matt, do you want to? There's a couple of solutions to work around that, right? So, and I don't know, the Zen Protocol, there's Lightning, there's sharding, there's a couple of different ways on how to enhance the sort of throughput for blockchains. What are your thoughts on you can pick one, or you can talk about your particular vision for it?
I'll try to talk a little bit more broadly. Generally, I think we see scaling solutions. The industry's kind of coined the terms like layer 1 scaling solutions, layer 2, and increasingly now we're talking about layer 3 scaling solutions. So layer 1 scaling solutions, as you can imagine, is on the blockchain itself. How do you design that network to be more efficient? Design it at the VM layer to be able to execute more transactions. Design it at the consensus layer to be able to validate on a faster basis. So that's a layer 1 scaling solution. A layer 2 scaling solution would be a solution like Lightning or Raiden, essentially a protocol that would sit on top of an existing public network. So in the Lightning context, it's Bitcoin that essentially provides almost like a payment system and uses the underlying blockchain as a settlement system. So you're going to run higher throughput transactions in Lightning, and then every so often you'll use the Bitcoin network to settle a lump sum of transactions rather than making every transaction go through the Bitcoin network. So essentially these layer 2 solutions are saying, well, how do I divert traffic off of the public infrastructure because it's slow and expensive? Essentially aggregate large numbers of transactions and only on like a lump sum basis take them and drop them into the underlying protocol. So there's lots of interesting research happening there. And then layer 3 solutions is where a lot of our focus is on this idea that you can start moving transaction throughput and transaction volume onto multiple chains. So that you can say, well, if I don't want to run into the lags and delays of CryptoKitties on the Ethereum blockchain, then I can run all of my application throughput on another blockchain and just revert final state back. So using Ethereum as an example, you've got models today that are emerging like there's a kind of test net that's increasingly being used in the Ethereum ecosystem called Kovan. Kovan is a proof of authority network. It's a faster throughput environment. It's got less traffic. So you're seeing transactions or applications building to essentially divert their traffic to the Kovan network and then essentially just have final state revert back to the Ethereum network. So you're using multiple blockchains that are essentially operating in parallel to each other, and then that interoperability or that communication protocol that bridges from one blockchain to another becomes like the critical piece of infrastructure that needs to be built in a way that it is trustworthy and decentralized and secure, because that then becomes the vulnerability in the system, right? Like you take a transaction out of Ethereum, which is relatively secure and well understood, and you move into a less secure kind of bridging environment, which is still in and of itself kind of a little micro network. That's the point at which there's vulnerability in the system. So the designs of these bridges becomes really critical to the security of the overall ecosystem. So what we're working on at Aon is, a big part of our focus is this bridging layer, and how do you move proofs of transactions from one blockchain to another as a solution for scaling.
Interesting. Smart contracts. Ben, do you want to talk a little bit about, your solution is very focused on smart contracts. There's a bunch of smart contract platforms out there. What do you think of Cohen and some of the other sort of current solutions that are being presented by some of the major smart contract platforms?
Sure. Thanks, Konstantin. Unfortunately, I don't have an analogy which involves oatmeal, which puts me at a bit of a disadvantage. So if you look at smart contracts at the moment, it's amazing what we've all achieved in such a small amount of time. And who would have thought, 10 years ago, we would have, decentralized programmable computer that we could all use and all that kind of good stuff. It's incredible. However, there's still some deficiencies in the programming language ecosystem itself. For one, if you look at some of the programming languages that are out there at the moment, they're very generalized, so you can get into situations where you can write bugs without realizing. The second problem is around upgrading. It's very difficult to upgrade all of these smart programming languages. So if you can imagine a Fortune 100 company, they're in a constant state of flux and disarray. What you're saying by having a non-upgradable contract is you're never going to change your business process, you're never going to change your business logic. So clearly it's unrealistic. Another challenge that you see with these languages has to do with the way that they are compiled. So for those that don't have a programming background, you write a language you write a program in a language that a human understands. You then compile it down to something that a computer understands, and then it just executes. Well, that's great, but unfortunately, in the world we live today, you inherit bits of code from other areas as well. Now, that's fine if you know what the code is, but when things are compiled, all you see is just ones and zeros that are impenetrable to humans. So you're trusting that whatever you're inheriting with will actually be what you think it is, but it might not be. What's more, and you may be familiar with this thing called leftpad, which destroyed the internet temporarily, a tiny bit of code that exists in the internet that Facebook used and Amazon used and lots of different services use. And it's about 10 lines long, and then the owner just took it off the internet. Everything collapsed and broke. Imagine that in a high critical transactional system with billions of transactions. That's part of the challenge we're going to face at the moment with some of these languages. So we, as Kadena, are looking to solve that through upgradability, through using this smart programming language that humans can understand and doesn't have some of those problems that I outlined before.
Great, thanks. Adam, you want to, I'm kind of curious, what do you think of Solidity as a programming language, and how do you guys relate to that? What do you guys use? And then the other thing is, I was thinking, are you guys a sidechain? Like, how does Zen Protocol sort of define itself?
Sure. So before I answer that, I think that I'd just like to touch on one thing about the scaling part, which I think just like public service kind of thing. So I think there's three things that should be appreciated when people discuss scaling. There's essentially, you have the amount of time it takes to compute a transaction, you have the amount of time it takes to propagate that transaction, and you have the amount of time, the amount of weight it essentially is placing on your node. So like, the storage requirement. So those are like the three considerations that I think should be taken into account when, you're trying to evaluate scaling these systems. Back to your question about Solidity, I think it's JavaScript. So what that does is it makes Ethereum a great place where a lot of people can play with it. So basically anyone can within 12 hours or 24 hours learn how to code in Solidity and start and go at it. And that makes Ethereum a great test bed for all these test applications. The problem with it is the fact that I don't think that the distribution is really normal. It's not like you have a distribution where, It's okay for some things to fail and some things not. It's essentially everyone wants to do the same thing. So you see it's like either ERC20 or DAO, right? And those are like two different extremes of the scale. So either everyone wants to do the exact same thing, or when you want to innovate, you have this like this exactly on the other end of the spectrum kind of effect. And I think that the language we're using, which is F-star, which is a language which, excuse the pun, I know it's kind of got a bad reputation in this space. It's a formally verified language built by Microsoft that has all these nice properties. What it does is it creates a great paradigm where essentially, if you want to do the standard stuff, if you want to issue a token, if you want to create a derivative, if you want to do that kind of standard kind of stuff, that's just like a template. You can do that easily. But then if you want to go ahead and you want to develop something new, you want to develop a new kind of functionality that no one ever thought of, well, that maybe requires a higher barrier to entry. And I think that's very good, actually, because I don't think you want web devs, building spaceships, and that's fine. So those are my thoughts on it.
Yeah, no, it's great. Thanks. All right, I'm conscious of time, and I do want to open it up for questions, but maybe quickly, so in terms of, people make these comparisons with where we are in blockchain compared to the internet, like, ranging from 1994 to 2000. Maybe quickly, just since you guys are all tackling the current inefficiencies of blockchains, where do you think we are in terms of mass adoption compared to the internet?
It's probably a stupid game to try to guess because we're all going to be wrong. I think what is worth keeping in mind though is what are we prioritizing? And you hear, the industry today has kind of, unfortunately, I think there's a lot of like people's marketing slogans, and they're not very good marketing slogans, but they come down to like, what's my performance on my blockchain, right? What's the transaction per second throughput I can manage? Generally speaking, I think that's a consideration that should come later. I think, to Adam's point, a lot of effort needs to be put into security, formal verification of languages to build applications that are robust and secure and execute as intended before we start worrying about optimizing for performance exclusively. We're still a relatively niche industry. As much as we criticize Ethereum and Bitcoin, they serve their purpose for the time being. And I think if we design with kind of security as the first guiding principle, performance optimization will come second. I suspect we're still at least a decade away from mainstream, kind of broad mainstream adoption of these technologies, beyond people holding a few coins in their portfolios for exposure.
Okay, great. Justin.
You can often hear there's people talk about, well, Bitcoin might be the first, maybe that's MySpace, and then maybe there's maybe there's going to be a Facebook. I tend to look at, Bitcoin as something very unique and special because it's attracted the amount of mining power that it's garnered. And Matt, to your point, I agree that, security is not efficient by its very nature. So from where we sit, we see an ecosystem that's going to grow from trees of chains, just another way to scale, if you will. So any project can have the market deciding whether or not it has value or not, and not everything resting within one ecosystem per se. So we at Veriblock try to complement any blockchain that exists and let their markets and their constituents decide if they're worthy or not. So we don't really have a dog in that fight. We just want to offer a higher level of security that you have already. So we don't have a contention with federated solutions, side chains, et cetera. We see ourselves as a complement to those because you can have a side chain, which to your analogy, we kind of see as Fort Knox. You've got your gold, but you put it in a Brinks truck. And now the Brinks truck's driving around with the gold. So your gold is at risk in the Brinks truck. What we like to say is, wouldn't it be nice if there was a dome where you could have Fort Knox underneath, pull your gold out and drive your Brinks truck all around, and before someone got into your Brinks truck, they'd have to get into the dome, and that dome is Bitcoin. So that's why we don't see Bitcoin as a MySpace by any stretch of the imagination. We see Bitcoin as the internet of proof. It's the world's greatest form and utility of proof, and it's extraordinarily efficient, and it's highly scalable, contrary to most people's belief. The problem with Bitcoin scaling is its narrative, not its ability to scale. If you want security, it costs money. It's not cheap to secure something. So Bitcoin, last time I checked, does not have a scalability problem with its transaction fee. If you want to be in the next Bitcoin block, put your money up, and I'm sure that the miners are happy to take it if you're willing to pay more than somebody else. So we don't see Bitcoin with a scaling problem. We see a scaling problem in the ecosystem as a whole, And I'd like to hear ideas like Matt and the other panelists and other protocols, and obviously approaching things like high transactions. We want to complement those ideas. We don't want to get into the narratives and the debates about what's this and that, because frankly, that's a lot to tackle. And it's one thing for Matt to focus on his deal and have to focus on all the other protocols. That's a lot of work. So we just want to come in and offer security for that. But 1994.
I think you really got a story of two parts. I mean, I'm from an enterprise background. I used to work for consultancies and tier one financial institutions where the wheels move very, very slowly indeed. And the challenge is, on that side, no one ever got fired for just putting in a database, using IBM, all that kind of good stuff, because there's no inherent risk. I mean, sure, your business model may be dying slowly, but it won't die quick enough that you won't have moved on to another job by the time you're finished there. So I think if one of the pieces that we're trying to solve for is you've got to make it so it feels riskless. The analogy I like to use is a bit like self-driving cars, right? Even though self-driving cars are obviously far more secure and safe and kill fewer people than cars today, it just takes one person to get run over and they're like, oh, that's it, it's too risky, we shouldn't have gone there. And blockchain's the same. And can you imagine in a Fortune 500 company being the one that's going to stick your hand up and saying, I'm going to take this experimental technology and I'm going to put $1 billion of flow on there? I mean, you're going to be crossing your fingers. I mean, I know the DTCC, for example, at the moment with their implementation, they're running into challenges, and they have $1.4 quadrillion that they manage on an annual basis. So it's about getting that enterprise happy that it's more secure and faster and better than what they have at the moment, not just as good, to make it worth the implementation risk. I think it's easier on that public chain side because you can have new organizations who are a little bit more entrepreneurial by nature who can innovate around that. And that's also kind of the story of the internet to a certain extent. A lot of those large Fortune 500 companies were disintermediated because of the entrepreneurs that jumped on board. So I think we're now getting to the point where we have the tools to allow that to happen.
To answer that question, I think that the question needs to be framed in, what is the blockchain really being adopted as? I think to Matt's point of saying, people are just holding these currencies with it or these instruments, and I think that's true. Barry Silbert, I remember him saying, I think back was like 2014 or so, he's saying that's going to be the killer app of Bitcoin. People are just going to hoard it, and that's fine, and that's actually what you should be doing. And I think that's what's going to happen in the blockchain space as well. So I think that our expectations may differ. I think in 10 years from now, people will realize that most of the use cases that they imagine won't go on the blockchain, and using it as a currency or as these financial instruments will. I'd say we're 1% or 2% of the way of what it's actually going to happen. So we probably still have another decade ahead of us, but we're definitely on track for that happening. I've got to say, I'm actually involved now with a project where there's a government issuing its first fiat currency now, on a blockchain. So it's interesting to see. A small government, but still, it's interesting to see.
Barbados?
No. But it's interesting to see. It's actually, it's taking its steps. So I'd say things are going well.
Thank you, guys. We'll open up for questions. We just have a few minutes left. Are there any questions from the audience? Gentleman over there.
Yeah, I have a question for Anna specifically. When you said Ethereum, sorry, thanks. Ethereum virtual machine kind of introduced lots of overhead, and the Solidity as a programming language itself is not necessarily the optimal language to program. But when you actually use the language invented by Microsoft, how do you actually embrace the talents who just become developers from other backgrounds? For example, I'm a C++ programmer, and where Quantum approach us with x86 VM, where I can just program my native language. What's your take on that?
Sure. So my take, it's not at all a knock on Ethereum, right? It's I think Ethereum is filling its role very well. I'd say it's even exceeding its role, because its initial role was to be a platform for innovation, experiment. It came, from my perspective on it, when I saw it coming into being, it was kind of Mastercoin wasn't flexible enough. We're going to have Ethereum. It's going to enable more flexibility. So that was the design goal of Ethereum, and I think that it's filled that very well. I don't think that necessarily people need to program on a blockchain. I think that it needs to do one thing. It's a weapon. Not everyone needs to know how to build weapons. They just need to work really well at that one thing they do. That's my take on it.
Anyone else?
I mean, maybe just a thought to add to that question. I think naturally over the course of the next few years, we're going to see execution environments on blockchains that are flexible enough to allow for a multitude of different languages to be used at the application layer. I don't think we're going to see the ecosystem emerge around a single smart contracting language. In the same way that, as you said, developers today that work in different domains and different industries tend to specialize in different languages because languages are built with different characteristics for speed of development or robustness of the final application, whatever. I think the same thing's going to happen here. I think we're going to see a multitude of languages, and then it's going to be a matter of how do we design that optimal execution environment that is flexible enough to compile multiple languages into its execution. So I suspect you're going to see new VM designs, and many of which are already kind of hitting the market today, at least in proposal stage, some in early proof of concept, that will rely on compilers that are flexible enough to take in multiple different smart contracting languages and still execute them down on the same VM. And hopefully, I think one of the big things that would be interesting to see unlocked, something that we're researching pretty extensively, is the idea of unlocking parallel transaction processing without putting at risk transaction dependency. Whereas the EVM is a great example of a significant bottleneck on the EVM is that everything gets executed in sequence because there's a risk of dependencies and transactions contradicting the same state on the chain. So to the extent that you can essentially eliminate that risk, verify for transaction dependencies, and if none, allow for transactions to execute in theory an infinite number of parallel threads, you should be able to see processing on these blockchains kind of increase a lot over the course of the next few years.
Thank you. I think that's our time. One more question? Yeah.
I have a question for Matt and Justin about moving between blockchains. So I guess I understand why you would want to move from a more established blockchain to a less established one for reasons of speed and efficiency. So let's say I have an application, I move from Bitcoin to some other chain, and then I move back because now Bitcoin's not clogged with some mass transactions. What happens if that other chain now gets attacked? Does that mean I lose that part of the history of whatever application I'm trying to build on the distributed network?
I think a lot of that will come down to the designs that the application developer uses. Whether you're doing dual implementation where the logic is kind of executing twice. We're working on a few projects right now. Bancor is a good example of a partner of ours that has built its entire system on Ethereum and is now testing the duplication of that logic on top of Aeon. So, in theory, you'd end up with a redundancy in terms of where the logic is being executed. We see this a little bit more as wanting to provide the flexibility for application developers to write logic that is reliant on events that are happening in multiple environments. So if you have an event happening on Ethereum and you want that event to trigger a piece of your smart contract, but your smart contract should then go trigger a transaction on another chain, where do you write that application today? Today, that application can't be written in a decentralized form. The only way to write applications that rely on multiple blockchains is to centralize the logic of that application on some sort of server that kind of connects through APIs to different blockchains. So part of our design is to say, hey, could I build an application that does a simple logical sequence like if this happens on chain A, then do this on chain B, and make sure that that logic is still housed in a decentralized application. That's not possible today. There is obviously the risk, and this is up to the application developer, that chain A or chain B are less or more secure than one another, and then you're relying on a chain that might be more centralized, less secure, whatever the case might be. I mean, the example I was talking about earlier, the Coven network, the trade-off people are making by going to the Coven network is you're essentially relying on the fact that it's 8 trusted nodes that are processing transactions on Coven. And so you're reintroducing a layer of trust and a layer of centrality. So it really comes down to the trade-offs and the requirements of your app. Not everybody needs to be on the most decentralized infrastructure at all times. I think there is an argument to be made that you can build across the spectrum from completely centralized solutions to completely decentralized and leverage the benefits and trade-offs of both.
So philosophically, I couldn't agree more on a lot of things that you're saying. What he's talking about in regards to there's certain things you can't do right now because blockchains are self-aware. They don't really know what's going on outside of themselves. So when you look at things like what proof of proof does, we allow blockchains to, for example, what he's talking about, you might have some type of a federation that's making decisions on behalf of they're acting as kind of an interface or a gateway of information, like an Oracle. With certain services or processes or APIs, whatever it wants to offer the ecosystem. What we can do, to what Matt said is, sometimes you can have a dance and do your thing. You can do these transactions. They don't necessarily need to be on a completely decentralized, trustless solution. And that's the thing, like we talk about private blockchains or private distributed ledgers, as I prefer to call them. You can do your business. You can do these things that you need to do. Maybe you're in the bubblegum business and you want to do a high volume of bubblegum transactions. Well, do you really want to pay a plumber to cut your grass, right? Do you want to go to Bitcoin and do your bubblegum transaction on Bitcoin? It doesn't make sense. But you can go do it on a low-risk network. Remember that oatmeal analogy I gave you? I don't want to go put my hand through oatmeal to get to a piece of bubblegum. I'll just go buy my bubblegum. It's much easier. And in that sense, what Matt's talking about, I couldn't agree more. It just makes sense to do things, and I don't even consider it like off-chain per se. It could just be a blockchain that doesn't have to have crazy levels of security because there isn't crazy levels of risk. Security, by nature, is not efficient. Transactions can be really efficient in a centralized manner. So the question is, how much time do you need in order to do these things, and at what point do you want to consider that transaction secure? I can do an off-chain transaction, moving 1 billion transactions, 1 trillion transactions in X period of time, whatever it is. And then when everybody agrees to the state, you can publish that state to a Bitcoin-type network. And then everybody gets what they want. And then you can move forward and transfer the value, et cetera, after you know that data has been secured, depending on the risk portfolio or profile that is satisfactory to you.
Yeah, sure.
So 2 quick things. Did you see the presentation by Jeff Garzik about Metronome? Yeah. Okay. So if you have an asset that you want inter-blockchain interoperability, and I also like the notion that you don't trigger a tax event, which I thought was interesting. That would be one aspect of asset transfer between intra-blockchains. To the other side of the equation, let's just look at a sidechain, for example. So you've got your Fort Knox, you move the gold out, you're driving your little truck around, a bunch of bandits attack you, and now your gold's, it's not really, it's an encumbered, basically a sidechain is an encumbered version of Bitcoin, in the Bitcoin analogy. So while you're driving around and you're in that state, there's going to be some type of protocol that's going to happen in the sidechain protocol that's going to make those decisions about interchain operability. So that's going to be specific to that protocol. So in the event that as long as that sidechain is securing itself, ultimately its blockchain data, up to a superior form of proof of work that can act as the end-all be-all, then inevitably I would think a protocol would have a way to resolve that. But it would be, you wouldn't just have this ubiquitous protocol. You can jump around blockchains with wanton abandonment. They'd have to be protocol, have some type of awareness of the network that they're moving within.
Right, all right. Yeah, off-chain stuff off stage, I guess, is, yeah,
I think
so
Matt had a comment he wanted to
yeah.
Well, the only last thought, 2 seconds, is, root. You can take the root hash of any network out there and prove it on another blockchain. So, the idea behind proof of proof, as far as I understand it, is exactly that, kind of a design for how do you do that. So you want to add some certainty to what you're doing. You're saying, hey, somebody may have gone in and tampered with historical transactions on a blockchain that's less secure. So long as you're very, very regularly taking the root of that blockchain and publishing it on another blockchain. You can do that 1,000 times over if you feel like it. And every time you do it, you add a certain level of certainty or security that I can go back and double check the source, right? And I can prove myself. I can go independently and take my transaction and compare it against that root and say, was that transaction included that root at any point in time, and have some confidence that the transaction is authentic or not.
All right, we're out of time. Thank you so much, guys. And then, any other questions, you can pass to them off stage.
Thank you.
Thank you.
All right, give it up for the great panel.